Let's take a look at diode logic gates. Now, back in the 50s, the first IBM computers that were solid state used diode logic, okay? And we'll go through a few of them. So this is a truth table. So you can see that for an OR gate, A can be, if A is energized or high and or B is high, then the light's going to be on. If they're both low, then the LED is going to be off, okay? So if one input's high, then the output's going to be high. Now this is a NOR gate and not OR gate, it's just the opposite. So if A and B are both grounded, then the light's going to be on, okay? If they're grounded, then you're just going to have voltage between, you'll have your 5 volts between here and ground through the LED and the resistor, so it's going to light up. Now if you put power on one of these, it's the voltage 5 volts over here, you're going to get 4.5 volts or 4.4 volts over here, your 5 minus your voltage drop, right? So that means that between this point here, there are 5 volts, and here 4.4 volts, you're only going to have 0.6 volts drop across your LED, so your LED won't light up. So if all inputs are low, then the output's going to be high. Now the Apollo guidance computer was built entirely from NOR gates, and you can build up all these other gates with just using NOR gates. Now of course they didn't use diode logic because every time you go through a diode you're going to drop 0.6 volts. So they used transistor logic down here, and this is what they used for one NOR gate. And I think they had 2 of these units, four transistors on one chip. Now over here for an AND gate, you have to have A and B on at the same time, and that'll light up the LED. So if you have 5 volts on A and 5 volts on B, the LED is going to light up. So if you have 5 volts on these two and you have 5 volts here, nothing can flow through this way because you need 5.6 volts for current to flow that way. So it's just going to go from this point down to this point, and you're going to drop your 2 volts across your LED. And these resistors are the same, so probably 1.5 volts here and 1.5 volts here, and then you can drop your 2 volts across your LED, so it's going to light up. So if all inputs are high, then the output's going to be high. Now if one of them's low, or they're both low, then current's going to flow to ground, from here to ground, and that's only going to leave you 0.6 volts at this point here. And so from this point down to ground, you only have 0.6 volts, so the LED is going to be off, okay? So if all inputs are high, the output's going to be high. Now this is a NAND gate and not AND gate. So the output's going to be on if these are both low, or one of them's high. So as long as one of them's low, the output's going to be on, okay? If both of them are high, then the output's going to be off. So what happens here, if these are both high, then you have your voltage from here to here. It goes through this voltage divider here. And this is a 1K and this is a 2K. So that means that at this point here, you're going to have 3.75 volts on this, at this point right here. And so you'll have 5 volts here, 3.75 volts here. That means you only have 1.25 volts here. And going through this resistor here, you're not going to get your 2 volts to turn on your LED, so this is going to be off. So if these two are high, then the output, the LED is going to be off, okay? So if one input's low, the output is high, okay? So if this one goes low, then you're going to have your 0.6 volts drop over here, and that means that you can have your voltage from this point to this point will be 4.4 volts, which is enough to turn on your LED here. And then I made up the same one with a DTL circuit, so a transistor logic here. That way you can cascade more of these things together, because every time you go through a diode, you're dropping your 6 volts, but this way you can get your voltage back with your transistor DTL circuit, okay? So I made up a few of them on here, and we'll see see if they work. So this first one here, we have this is our OR gate. So if I light up one or the other one, it'll come on. or if I put them on both of them, it comes on. And this is our NOR gate. So the truth table on NOR gate says that it's on because these are both grounded. But if I put power to one of them, it's going to turn off. I put power to this one, it's going to turn off, or power to both of them like that, it's going to turn off. So that's your NOR gate. Now, this is an AND gate here. So on your AND gate, we need to have these grounded, okay? I'm going to ground both of those. Okay. So on your AND gate, if they're both grounded, it's going to be off. If we put one of them high, which I did, it is there, it's still off. I ground that one, put this one high, it's still off. Now, the only way it's going to be on is if I put them both high here, then it's going to come on. So if they're both grounded, then it'll be off. Now, but if I pull those out, it comes on because I'm not ground. These aren't grounded here. I could put resistors in there to ground them. So this is going to be your NAND gate, not AND gate, right? So if I ground these, one of them, it should be on. Let's see if it works. Yep. And if I ground this one, it should be on. And if I ground them both, they should be on. Okay. And it should be off if they're both high. So I'm going to put them both high, and it should go off. Okay. Now, this is your, this one here is this one down here with the transistor logic, and we'll see what that does. So, to get them off, it's off right now. To get them on, you have to ground one of them, which I did. Okay, or you ground this one, and it goes on. So it doesn't really matter if there's power on. It works with the ground. Okay. Oops. So ground that one, and it comes on. So one of them they both have to be grounded, or one has to be grounded to come off. But if we don't put voltage on them, then it's going to be off. Okay. So, and if I put voltage on them, on these two, it's still off. So it's got 5 volts on it. This one's got 5 volts on it, and so they're still off. So in a switching circuit, you would keep 5 volts on there, and then you would go to ground with one of them to turn it on and off. So that's our logic gates, and so that's how they work like that. I'll put a link to the to this notes here in the description. So that's Diode Logic. Thank you.